Hello, this is Rohit Kumar, and today I'm going to present my research project, which is intracranial brain hemorrhage detection using deep learning and multiple instance learning. Moving further, intracranial hemorrhage is a type of uh, serious stroke that can affect people of all ages, particularly those with high blood pressure. It occurs due to blood leakage into brain tissue from damaged blood vessel, posing a serious threat to a person's health. Five different types of intracranial hemorrhage are subarachnoid, intraparenchymal, subdural, intraventricular, and epidural hemorrhage. Research question: how well can we detect brain intracranial hemorrhage using deep learning and transfer learning? So the CRISP-DM methodology is used for this, and that follows business understanding, data preparation, modeling, evaluation, and data presentation. Model: CNN, dense net one-to-one, and exception model is used for this. Design architecture. So the design architecture follow: we input CT image in DICOM format. Mm, we get this data from the Kaggle API. Then we use CT images and change is window width and window length using windowing to resize it in a three-channel subdural bone and brain, and then the full data set is feed to CNN DenseNet one-to-one and exception for further prediction. Is the image have what type of image have uh, intracranial hemorrhage? The evaluation is done using comparison and interpretation of result based on precision, accuracy, recall, F1 score, area under ROC curve, model accuracy, and model loss plot. Ethics: the data is fully anonymized from any individual patient information at the source level, and it is publicly available and downloaded from Kaggle, confirming its adherence to the GDPR compliance. Moving forward to the report, the report is start with the abstract and then following introduction where I have mentioned about intracranial types and some why is this need, why this project is very important in medical sector. If we have like any fast deep learning models, then it will really help people to save their life, because we can early detect the bleeding area. The research objective: five objective six objects is set like using the models, and the evaluation matrix is on based on accuracy, precision, recall, loss function. In related work, two subsection use deep learning using CNN and deep learning using transfer flow. So in the previous study, which is done on RSN data, shows very good result. Like they use 512 by 512 size and easy to get the percentage of 93.3. But this is very high image quality, and the data set is also is very large to progress. So in my study, I have choose for 128 by 128 dimensional shape. So this is the research work, and the second research work is done using transfer learning. The business understanding, then the business understanding of model, how this is important, then data understanding. The data have like six column in that way, where few images even don't have no hemorrhage, the value says zero. All of them six are in boolean shape. Then data processing is done, is mentioned how we process. First is image conversion, is done from 512 pixel to uh, 128 by 128, and then windowing of the image is done uh, using window width and window level. Then this is three channel windowing is done, and modeling, CNN and DenseNet exception, and then after proposed design architecture using three layer, this is done. Implementation, the uh, environmental setup, what sort of technologies did we used in that. Data transformation, using convolution layer, and then transfer learning, and the evaluation is based on the accuracy and loss graph of all three models, and then their accuracy, precision, and at the end we find out the image. This is the actual image and this is the predictive image, and this image, we find out this has subarachnoid type of hemorrhage. Moving further to the code file, so this is the full process. First we have set the directory, and then we download the Kaggle in our device. So I mentioned there two methods. So the method I use to download this is through command prompt, but I mentioned this method as well, where we can actually set our user key and fetch the data after using this API key here, and then libraries fast to read the data. So the data set is really very big. It is around 460 gigabytes. When we unzip the file, the zipped file download through Kaggle is 191 gigabytes. This is the directory path set to fetch the data. So the main data set have four files. Two are them from stage train, and then one is train, one is test, and then two is one from training one, which have the label of train image, and this submission have the test one. So we have separated this and save as a data frame here, and then we check the data balance in there. And then moving further, like, because it is really very heavy data, and my device is not that super fast, so I use only 50,000 image from the train image folder, and I use 5,000 image in the test image folder. So for the further process, and then I choose 15% of train image data out of 50,000 to validate the models. And then the model is then processed through the windowing process. So here in this function I get the pixels of the image, and then windowing, three channel windowing is applied here. If this is minimum, if this is minimum value of the image, then it shows white, and if the value goes high, it will show the black image after windowing. So this is set in these all three image, and then here is resize function, where I give the directory to save my old data, and then give the resize unit here. So once I run this code, this file start loading here, and it straight away goes to my I give the directory I gave here. So here you can see the dimensions of the image is details is 128 120 pixel. Usually the format is 512 and by 512 dimensions shape. Then there is all the files I have, all the directories, all the libraries I have loaded here, run here, and then the generator function is used to um, fetch the data from the resize folder, and set the target column and the badge size for all three classes, and then the further model is applied. So here I use two function. So one deal with the learning rate reduction. I set the minimum learning rate to this, and this is the checkpoint which will be check the data progress and save time to time. So if the kernel break I will not lose my process progress. And here I have set up the CNN, and then I run the code here using 10 epochs. And validation steps is used like because I've used 50% data set, so this is what I use here. So the image data set run, and it is only in 22 minutes. uh, Here is the loss and training accuracy. So this is the confuser matrix I code using this using the prediction of this model. And then moving further to the dense net, this node shows like very high accuracy. It is only 86% accuracy shows, so that's why we implement transfer learning model, because they are really fast and they have like image in millions using this weight ImageNet database. So the denseNet is applied here, and following that, this the model is run on that, and the accuracy we have received in this is um, like little bit increase from CNN. It shows like 90%. So it is not still not enough for the image data set, because we are detecting bleeding in that. So here is the exception model I have used, and the on the image data set, and the dropout set to 0.15, so that we can avoid the overfitting, and learning rate is also fixed using that. And Adam optimizer is used as well. Adam optimizer as well actually used for CNN and densenet for that as well. So here is I applied the model. So the model took really long. It took 14-hour time, and this is the validation accuracy and low training and validation lows. The training accuracy is going way far high, so there's chance of overfitting here. So later for this, I applied ROC curve to check like is really there is overfitting or not. So I find really nice good prediction value here, and the accuracy of the model is better than the previous models. So I consider this model for prediction of my final prediction of the prediction with the final test results. So here I I use this I use the YPRADs to check the length here and save this in the data frame to drop the folder file name. And this is where I save my all probabilities of the image, like each type's image. And then same I have did in the using the test one. The test set is again uh, like testing is also used in this model to prediction. This is the exception generator. And then same they did dropping the file, and we have the probabilities of test here. And the final at the end, like we are able to see our predictions of the image, like on these probabilities this says any. So any, and any is like if you have any subtype, it will show any. So here if we'll see this in this accuracy, it is intraventricular type of hemorrhage. So in my report I have mentioned this. So like if this image, if we check is in this in our actual one, it will be show there. So here if we search the actual uh, so this is the image. So we find out this image have this image have the this image have intra intraverticular type of hemorrhage. So this is really good, like uh, to detect the subtypes of intracranial hemorrhage, because the data set is only 55,000. As it is 100% sure, like if we increase the data set, so the model will be really work well. Thank you.